Good evening, guys. Good evening, everybody. Manjunath, Santosh, Nikita, Sushant, Vinayak, everybody, good evening. So, to introduce myself, my name is Ramchandra. I am a postgraduate from IIT and I have been teaching the students for competitive examination for the past 15 years. Today we will be discussing about thermometer and thermal expansion. Before that, I would like to give a small introduction about the topic, at the same time about the competitive exams and other things. See, generally what happens is that in today's time, lakhs and lakhs of students, they take up these competitive examinations, but unfortunately very few get selected. And it's a very well known fact that now knowledge is not only the power. And I keep telling many of my students that, see, just by reading PCMB, you won't be able to pass this competitive examination or succeed in this competitive exam. You need little more. It's not just like about competitive examination. Yes, Vinayak, I am from IIT Roorkee. Thank you. So this competitive examination needs a little bit of extra things apart from PCMB. I keep telling this one in every of my class, and we have to look at all such stuff. Now, coming back to this particular topic from the examination point of view, I assume that all of you have gone through the theory part of this one. Nevertheless, we will be discussing about all the theory part which are essential for NEET and JEE at the same time, JEE mains. And these JEE mains, they have got an extra skill that is asked, because all the 20 lakh students, they would be knowing all the topics that you know. You need to learn a little extra. So this way you need to be a little more alert, because all the students, they know each and every topic what you know. So today this thermometer and thermal expansion, the first part of the thermal physics part, I will be discussing about this one now. So the prerequisite for this particular topic will be, you need to know extensive graphs, at the same time good mathematics. So look guys, graphs is a very essential tool in JEE mains. So because of that particular requirement, I suggest each and every student to start or practice plotting graphs for whatever the equation they feel like. That's very important. Now, goals for the class. First thing, we will be starting with thermometry. In that, temperature, scales of temperature, conversion of temperature from one scale to another scale, types of thermometers. Then next topic will be thermal expansion, linear, superficial, cubical expansion, application of thermal expansion in solids, bimetallic strip, effective of change in temperature and time period of a pendulum, thermal stress in a rigidly fixed rod, then expansion of cavity part. Then comes the thermal expansion of liquids, anomalous expansion of water, effect of temperature on upthrust, variation of density with temperature. These are the important things which we will be discussing today in this particular title, thermometry and expansion of gases. I am sorry, expansion of gases, a coefficient of volume expansion and coefficient of pressure expansion, these things. So guys, to give you a small introduction about these topics, first let us start with the temperature part. All of us, we know that temperature is a measure of, it's a science of measurement. The temperature is defined as the degree of hotness or coldness of a body. sometimes this hotness, degree of hotness or coldness of a body does mislead us. So what do? We need to have a proper way of measuring this, the degree of hotness. So temperature is one of the fundamental 7 fundamental quantity, and it's a scalar quantity as you know. So I am just brushing through all these things because I assume that you are all in the second year of JEE preparation or NEET preparation. And Shubham, good evening, thank you. And I know all of you must have gone through this one. We will concentrate more on the conceptual part of it. So the third one, what is this temperature? Basically it's the average kinetic energy of the molecules of a particular body. Yes, definitely Kunal, I will help you out with plotting the graphs in whichever may be the equation that we come across, definitely yes. So now let us move on to the scales of different temperatures. Now take a look at this one. There are generally in JEE mains and NEET 3 scales of temperature that we generally used. One is a Fahrenheit, another is Celsius, and the Kelvin temperature. So the first, let us have a small introduction of all these things. Fahrenheit scale, the scale has got an LFP. I have written here, down there, must be knowing, I am sure you are all observing this one. This LFP and UFP, it is being written here. LFP lower fixed point and UFP is upper fixed point. Now this scale, Fahrenheit scale, has got an LFP of -460 and UFP of 212. So you can notice here -460 here and 212 here. In between we have a freezing point of water here at 32 degree Fahrenheit, right. So between freezing point of water to boiling point of water, there are 180 different scales are there, and each degree, each graduation reaches 1 degree Fahrenheit of it, where upon comparison what you can notice is that 1 Fahrenheit will be 1 degree Fahrenheit will be less than 1 degree Celsius. Thus you can easily identify there. The second one, the Celsius scale, there is -273 is the bottommost point, 100 degrees Celsius is the uppermost point, where 0 degree Celsius is the water freezing point. Between water freezing point and boiling point we have 100 divisions on this scale. So then comes the Kelvin. This is also called as a thermodynamic scale. So it starts with the 0 Kelvin here and 373.15 Kelvin, and that is the boiling point of water. So total 373 divisions are there, and each division will read 1 Kelvin. So every graduation has got 1 Kelvin of graduation. 1 Kelvin per division or 1 degree Celsius, both are equal, while in the case of Fahrenheit it will be lesser than that one. Let us remember this one, because total number of divisions is kept as 180 divisions. So obviously against 100 you will have lesser values there. So next let us move on to the conversion of temperature from one scale to another. I am sure this particular concept, guys, remember some of the times everybody will get misled here. So be sure that this conversion of temperature from one scale to another scale, you practice it quite rigorously. So the first thing is that temperature on one scale from one scale to another scale can be converted by using this particular equation, that reading on one scale minus the LFP, remember LFP means lower fixed point, divided by upper fixed point minus lower fixed point. This is constant for all scales. While upper fixed point and the lower fixed point, this gives, you can also say that, number of divisions in any thermometer for that matter. So now if at all the scales are related to each other by this particular relation, you can remember and you can memorize this one. See, the first thing is the degree Celsius, this one here, C minus 0. C is any random reading, minus 0 is the lower fixed point, keeping water as the standard. Remember, every thermometer takes water as a standard, right? The temperatures of water as a standard, divided by upper fixed point minus lower fixed point, 100 minus 0, that comes out to be 100 again. Next, this is the Fahrenheit scale, F, that is any random temperature on Fahrenheit scale, minus 32, that is the freezing point of water, which is equal to 0 degree Celsius there, divided by upper fixed point, that is 212 minus 32, that is equal to, again this Kelvin, any random degree Celsius, minus 273.15 is the freezing point of water here. Remember, this is freezing point, divided by 317, that is the water boiling point, 273.15, this is freezing point again. This gives you total 100 divisions again. So simplifying that one, C by 5, which is equal to, take the common and try to simplify that one. This is the important equation for thermal expansion or conversion of one scale to another. C by 5 equals F minus 32 divided by 8 equals K minus 273 divided by 5. So this is an important equation for conversion of 1 to, what about absolute degree Celsius? You can convert that one, no problem at all. Taking this as a standard of freezing point of water to freezing point of boiling point of water, this is scale is been written. So degree Celsius from this, the total, this is the temperature on the Kelvin scale, this is 273.15, which is generally rounded off to 273 into whatever the temperature is there on the degree Celsius, that is T. So this is your absolute scale. Yes, of course. Dhruv, this is reading, not exactly reading the slides. I am just passing through the slides because all these things you must have heard about it. So that is the reason why I am trying to concentrate more on the subtle concept rather than spending more time on the explanations. And they are all just the informations, that's all. Not much of a mathematics or content is there in this one. So now let's go on to the types of thermometers. So on heating, many properties of matter changes, say in the sense like there may be a change in the length, there can be change in the volume, there can be change in the density, there can be change in color. Upon heating, you will see all these different properties of water, matter, which keeps on changing with the rise in temperature. So length, volume, density, resistance. Can anybody add some more quantities here on increasing the temperature? What other quantities can we think of changing? Next one is pressure. So different types of quantities will be there, which will be changing according to the increase in temperature. So depending on the magnitude of the change in temperature could also be measured. Yes, correct. Happen pressure, that's also right answer. Now if the thermodynamic property of a temperature, let's assume that length is one thermodynamic property, volume is another, color, resistance, pressure, these are all the thermodynamic properties. Thermodynamic property means any parameter that changes with the change in temperature, that we call it as, that can be told as thermodynamic property. So let's assume that at 0 degrees Celsius, 100 degrees Celsius and T degrees Celsius is x naught, x100 and xt. These are the different thermodynamic properties. This x can be anything. ध्रुव समझ में आ जाएगा, कोई दिक्कत नहीं है, आराम से बात कर लेंगे. So so now if at all, if we choose length or volume or density or color or resistance or pressure, we can form one common formula to measure the temperature due to the change in these parameters. Any of these, we can just substitute their subscripts or their notations and you will definitely get these values, the conversions, or you can find out what is the temperature and what is going to be that formula. So this formula will be T is any random temperature minus 0 degree Celsius divided by upper point minus the lower point. This will be equal to the thermodynamic property at random temperature x. X naught is the thermodynamic property at 0 degree Celsius and divided by this thermodynamic property at 100 degrees Celsius minus the thermodynamic property at again 0 degrees Celsius. So if you simplify this one, you will get T is equal to x minus x naught divided by, okay, you can take area also, no problem at all, divided by x100 minus x naught with into 100 degrees Celsius. So this equation, this can be used for any of the thermodynamic property to be found out. Let us say for example, if at all there can be a different temperatures or different thermometers using length, volume, density or whatever that may be. So T at a particular temperature, let us say length of a particular thing at random time T minus length of the expanded length at 0 degree Celsius divided by length 100 at boiling point and length at 0 into 100, this gives you the temperature of temperature of that particular thermometer, in that particular thermometer rather. Now we will try to see which are all the different thermometers that we can use or it has been used in scientific community. So one is liquid thermometers, the second one is gas thermometers, the third one is resistance thermometers as I earlier informed, and then thermoelectric thermometers, thermocouples you can say. Then pyrometers, yes, this pyrometers is an interesting one. This parameters, anybody knows about this parameter? हाँ जी, शुभम, मैं ज़्यादा हिंदी यूज़ करने की कोशिश करता हूँ, ज़्यादातर मेरे क्लासेस इंग्लिश में होते हैं इसलिए वो ऑटोमेटिकली आ जाता है. Then vapor pressure thermometers. Now let's go to this pyrometers. These pyrometers are the instruments or the thermometers used to measure high temperature, just like in the case of any steel plant. किसी जी liquid thermometer में mercury thermometer आता है, no problem at all. So, high temperature like in a steel plant, the molten steel or probably some other type of high temperature objects can be measured using pyrometers, because increasing temperature the bodies they change color. So, you can see that for a lower if you take for example एक कोई भी आयरन का ऑब्जेक्ट लोगे तो उसके साथ उसकी टेम्परेचर बढ़ाते रहोगे तो पहले तो ब्लैक दिखेगा, उसके बाद थोड़ा सा ब्राउन रेड होगा, उसके बाद थोड़ा सा ऑरेंजिश कलर होगा, उसके बाद येलो होगा, लेमन येलो, येलो, and then it goes to a complete almost like white. So, with increase in temperatures, objects they do change their colors. Yes, of course, from the amount of thermal radiation they emit also, because this thermal radiation they depends on the wavelength and colors are attributed to the wavelength. That's the correct one. Thanks a lot, Radhika. Yes, let's try to take up the problem, first problem, depending on all the concepts that we have so far discussed. So, try to change in, I will give you 30 seconds of time here. What will be the value of the following temperature on Kelvin scale? So, I have given you a formula there. I hope you would be able to solve this one. I am not seeing much of a response. Shailendra Kumar, Jyotsna, .37 degrees Celsius is 310 Kelvin. Perfect. This is Shailendra, right? Akashdeep, you are correct. Vinayak, सही है. अपेक्षा 310 सही है. 80 डिग्री फ़ारेनहाइट कोई बताओ जल्दी, 30 सेकंड से ज्यादा नहीं मिलेगा. ऑफ कोर्स इजी वन है. हाँ, $80 degree Fahrenheit. $353 and 196, 77K. Perfect. फ़ारेनहाइट का किसी ने बताया? फ़ारेनहाइट टू केल्विन. You can use the formula F minus 32 divided by 9. This is equal to K minus 0 divided by 100, right? .26 Kelvin is the correct answer. That's nice. Thanks a lot for your attention. Let's move on to the next problem. Of course, all these problems are definitely easy. Let's take up the second problem. A faulty thermometer has its lower fixed mark as -10 degree and upper fixed point marked as 110 degrees Celsius. If the temperature of the body shown in the scale is 62 degrees Celsius, the temperature shown in the Celsius scale will be. So, these are your options and you will have again 30 seconds time to answer this one. Is anybody there? -42°. That's perfect. Seems like Shailendra has got the right answers for most of the questions. So D is the correct answer. I hope I can move on to the next problem, I guess. So next let's take up this thermal expansion. Now we know that जब भी हम hit करते किसी object को, we know that they are going to expand. So this expansion, we say that it is due to a particular explanation, that we say that according to atomic theory of matter, there is an asymmetry in the potential energy curve which is responsible for this expansion of the matter. हाँ जी शैलेंद्र, मैं हिंदी भी यूज कर सकता हूँ, कोई दिक्कत नहीं है. So atomic theory of matter, there is an asymmetry in that one. Let's try to take that picture. So with the rise in temperature, the amplitude of the vibration, they are going to increase. So this is the reason. So let's take up this diagram here. This is the atomic separation, which generally it is written as R naught. And this is the energy the atoms they are going to gain. Okay. So now I'll come back to you. Arpan, I will come back to you. I'll definitely explain that one. I hope I started this concept, so that's why I can flow with this one. तो शुरू किया है तो खत्म करके वापस आ सकते हैं. So any responses? Can I proceed or should I get back? Okay, fine. So now x-axis we have taken R naught. This is the atomic separation. So this is the energy on the y-axis. With the increase in temperature, generally what happens at R is equal to this, at this particular point, at time t is equal to 0, they will be having the minimum separation as much as possible. Of course, there are certain other explanations also with uncertainty principle. It is not possible for them to have completely rest state. They have to keep vibrating. They have to have minimum energy. Okay, let us proceed from that one. So from T naught, if we increase the temperature, you can see that with the increase in temperature T1, from T naught to T1, with that difference in temperature, the amplitude is going to increase to, let us call this as R1. Next, so it will take energy and they will start oscillating with higher amplitude. If we increase the temperature to T2, from T1 to T2, if we increase this one, there is amplitude will increase from R1 to R2. So at every increase in increment in temperature, you can see that the amplitude of the atoms, the vibrating atoms or oscillating atoms, they are going to increase. So with that, this is the reason, because of this asymmetry, you can see that this is the asymmetry part here. It started with this one, but with every increase in temperature, this much of the extra amplitude is being gained. So because of which, on giving thermal energy, what is going to happen is that they start moving away from each other because of huge amplitude of oscillations, their oscillation. So obviously from point to 1 to T1, T2, T3, we can infer that R1 is greater, R2 is greater than, or R3 is greater than R2, which is greater than R1. So the energy also E3 is greater than E2, which is greater than E1. So this is the reason why there is a expansion in the body, in the matter. So there are different types of expansions that we can come across in the thermal expansions. Thermal expansion of solid, if at all we take, say there are three types of expansion that you know. Again here I will be just सब कुछ जो आपको पता है सब मैं इन फ्लो मैं बता दूंगा, क्योंकि यहाँ पे ज़्यादा कुछ सीखने को है नहीं, ज़्यादा से ज़्यादा फार्मूला से ज़्यादा है, तो इसलिए ज़्यादातर I will just be giving you the facts, that's all. So now when a linear expansion, in the case of a linear expansion, when an object of a linear dimension or one dimensional body like rod is heated, then the length is going to increase. You can see majority of the things I have made the animations here. So let's assume that this is a rod of length L naught, and you are going to increase the temperature for this rod. It's going to increase its length by delta L. So this we call it as linear expansion. We can say change in the length is given by delta L into L naught alpha delta T, where alpha is called as coefficient of linear expansion. The next one, the very important formula for this one is the final length L is equal to L naught into 1 plus alpha into delta T. So unit of alpha will be per degree Celsius or per Kelvin, right? So then next comes, apart from this linear dimensional expansion, we have aerial also. When heat is transmitted to a 2D object, just like a plate or any two-dimensional object, the area it's going to increase. Let's assume that this has got an area A, and if you increase the temperature, there will be an increase in this much of area. We can call this as delta A. So the change in area, as you know, that delta A will be equal to A naught beta T, where beta is called as the coefficient of superficial expansion, and then final area, and then the unit of beta. So these are some routine things which requires very less explanation. That is the reason what I'm doing is that I'm just giving you the facts. Wherever there is an explanation required for the concept, I will come back to that particular part. So now the third one is cubical or volume expansion. So when a solid is heated, it changes its size in all the three dimensions. So this is called as a cubical expansion. Let's assume this is a solid cube. When after the increase in temperature, the volume will be increased to this extent, dV. So the change in volume will be dV. So the change in volume, this dV can be given as V naught into gamma into delta T. So gamma is called as the coefficient of volume, cubical or volume expansion. The final volume can be calculated with this equation, V is equal to V naught 1 plus gamma into delta T. The unit of gamma, again it will be per degree Celsius or per degree Kelvin. So generally Fahrenheit is not used here. Now moving on to the next one, the relationship between alpha, beta and gamma, it will be 1:2:3. Yes, Shailendra, I will explain that problem, no problem at all. The next problem, we will just go to the next one. When a metal sphere is heated, the largest percentage change will occur in its diameter, density, volume and area. So again you have 20 seconds time for this one. Anybody? Volume, diameter, density and area. Let's try to check each and every one, every option here. Let's try to understand this. Diameter is, we know that with the increase in temperature, when the metal sphere is heated, the temperature is going to increase. Diameter is given by d is equal to r by 2, where r is a linear dimension, right. So because of which probably the diameter will have one type of change. Density is given by this mass into volume. With the increase in temperature, mass is not going to change. So volume is given by, we know that 4 by 3 pi r cube, and area is given by pi r square. For the change, we are looking at the percentage increase in this one. Let's try to differentiate this. D, we can say delta V is equal to delta R divided by 2. So it's quite linear. But in this case, there will be a minus sign. Delta rho will be equal to minus times 3 times delta R. And here, as we know that delta V will be equal to 3 times delta R, and here delta A will be equal to proportional, you can say, not exactly equal, you can say proportional. This will be equal to 2 times delta R. These are the changes what we are expecting. The maximum change is in the case of volume. So that is the reason why there will be the largest percentage increase will occur in the case of the physical quantity volume. I will come back to that one, Shailendra, very soon. You know, yadu fine, sure. So let's take up the third problem. The radius of a metal sphere at a temperature T is R, and the coefficient of linear expansion of the metal is alpha. The sphere is heated a little by the temperature delta T, so that the new temperature becomes T plus delta T. The increase in volume of the sphere is approximately. You have these options. Probably you can answer it pretty easily, because the previous answer was quite fast and at the same time it was correct. Most of you got it right. So that's why I assume that you will get this also right. So I got 30 seconds to go. Okay. Okay. Okay, fine. Continue ಮಾಡಬೇಕಾ? Okay, so the answer will be, should I explain or okay. Yes, the answer is correct, 4 by 3 pi r cube alpha into T, right. So the metal sphere of at a temperature T, it has got a radius r and the coefficient of linear expansion is this one. You know, again the same thing is that volume is given by 4 by 3 pi r cube or this r cube, right. So the change in, excuse me, need a small break. How that? Okay. ಚೂರು ನಂಗೊಂದು ಸಣ್ಣ ಬ್ರೇಕ್ ಬೇಕು. Okay. Okay, fine. So let's move on to the application of thermal expansion of solids. There are different thermal expansion of the applications of thermal expansion in the case of this one. One is bimetallic strip. What exactly they do is that दो metal strips को join करेंगे, different metal strips having different alpha. So let's say this is alpha 1 and this is alpha 2. Okay. Whenever upon heating they are going to bend in the side whichever is having lesser alpha, because the greater alpha will take more time. This may be having lesser alpha compared to the second one. So this is how we can make and break contacts in the case of electrical circuits. So the second one is, effect on the time period. Generally these are the common questions in JEE. So the pendulum that keeps, let's assume that there is a pendulum that's going to keep a proper time at a temperature theta, that changes its time period when the time is, it's going to, temperature changes to theta dash. So due to linear expansion of length in the pendulum, the fractional time period is given by delta t by t is equal to 1 by alpha into delta t. You can derive this one, t is equal to 2 pi root of L by G, since L is a, okay, sure, L is a linear dimension, so the t will be directly proportional to root L. So here if the length changes, automatically the time period is going to change. So in the case of summer time, there will be theta, if at all greater than theta, the clock will lose the time and become slow, and if at all it gains, it generally in the winter time. So thermal stress inside, in the case of a rigid body, fixed body, there will be a thermal stress. Just a minute. So these thermal stresses, it can be given by delta L by L, which is equal to alpha into T. This is the thermal strain, and thermal stress is Y is Young's modulus, and force that supports these two. Let's assume that there is a rod which is fixed at two different edges. This will be applying a force in both the directions, and that force can be given by Y which is Young's modulus. A is the area of the rod, alpha is the linear expansion, delta T. So in the case of there can be error in the case of a scale reading, and then the true value can be given by 1 minus alpha into delta T. I'm sorry, this is plus, and true value in the case of scale reading, this will be 1 plus alpha into delta T. So the second thing is the expansion of the cavity. Generally this is a question which is asked by many people, that if at all there is a hole in a plate, and if we are going to increase the temperature of that particular plate, then probably what could be the area. What could be the change in area? Generally change in the area of the hole. Generally, you know, there is a question saying that why can't there can be a decrease in area, because the plate can, you know, change in the inward also, it can increase in the inward direction also. If we assume this part of the, you know, plate or the hole is being fixed there, it's scooped out of that hole and it is fixed there, so we can expect the entire area to increase, and at the same time this also should increase by a delta R if you increase the delta by delta T. So that is the reason we can say this is a reverse mechanism by which we can explain this one. So the previous contest question, probably this was the question that was given to you people. What is the focal length of a biconvex lens, each of radius of curvature R, with mu equals 3/4? Nobody has got the correct answer, it seems. So the answer, it seems to be R itself. So this is the previous contest question. So my contest question, I will throw it now with to all of you. Here a body is floating in a liquid and the height of the liquid is marked as H0. If we increase the temperature of the liquid and again H1 is marked, then so you have 30 seconds to answer this question. Divyansh, Shailendra, Akashdeep, Radhika, Deepak. Okay guys, let me give you the correct answer. The correct answer is, the correct answer will be announced in the next class. So let's move on to thermal expansion in liquids. One is the coefficient of apparent expansion. Yes, again I will just flow through this one. Let's assume that there is a container and in which the liquid is being heated. So first thing what we need to do is that we have to take care of the the apparent expansion, coefficient of real expansion. Apparent expansion is given by the real expansion in volume divided by initial volume divided into change in delta theta. Now the next thing is that coefficient of real expansion, it is due to the actual increase in the volume of the liquid due to heating. This is given by this particular formula. I am sure all of you know these formulas because it is pretty old, rather this is a revision class. So it is very important for us to finish the classes as well. So there is a expansion in the case of vessel as well. So this here in the case of vessel, you know, it is given by delta V of the vessel divided by change in fractional change in volume divided by change in the temperature. So the calculation, the real expansion is given by apparent plus the vessel. Let's say I will try to explain a little bit of this one. When you are, you know, heating a particular vessel which is filled with liquid, along with the liquid the material, the vessel is also going to expand, for which generally the height of the liquid will decrease in the beginning, after that it will increase. So that is the reason why we have to take care of all these apparent expansions and real expansions. So the change in volume of a real of a liquid relative to vessel, this can be given in with these formulas. So the anomalous behavior of the water, next. Okay, all these things I will explain in the next class a little bit, and let's go to the next slide. Next slide. So next important so summary of the class. In today's class we have discussed the thermometry, temperature, scales of temperature, conversion of temperature, and then types of temperature. In the thermal expansion we could make into linear, superficial and cubical. In the case of thermal expansion of solids, bimetallic strip, effect of temperature on time, thermal stress and expansion of the cavity we could discuss, and these other two I will discuss it in probably in the next class. So thanks a lot for joining my class. I will try to make it more Hindi in the next classes as much as possible. Hope all of you have enjoyed this particular class. Yes, though it was my first one. Okay. So passport users, start solving the questions at the right time, so that it will help you for your examinations in the upcoming examinations. And I thank you. Have a nice time and have a good night.